U7.04. We're going to use technology to estimate the areas under a normal curve in context. So this is just going to be a follow-up from what we've worked on today, and hopefully you'll feel really confident in understanding how you're computing the area under the curve and what it means in the context of the problem. So just a quick refresher. A z-score tells us the number of standard deviations that a particular value is above or below the mean. Obviously a positive z-score means it's above that many, and a negative means it's below the mean by that many standard deviations. And then using a normal curve to find a probability, it's actually very simple. So just the idea behind it, right, is that a normal curve has an area underneath the curve of 1, right, because it represents all of the data. And so all of the data is one whole, or 100% of the data. And so what we would like to know is the probability that our data is in some particular interval. And that just boils down to finding the area underneath the curve in that particular interval. Because the area underneath the curve will be some decimal less than 1, and so the proportion out of 1 will just be the probability. So just to give you an example, say that we found the area under this curve to be 0.847, and that is out of the total area of 1. And so that's 84.7% of the data, right? So 84.7% of the data is this shaded piece here, and so you would expect, the probability that if you were to pick a random data point and it would be in this interval is about 84.7% or 0.847. Okay? And so what we need to do is determine the z-scores between which the event we're interested about exists. So if it exists between these two, we compute these two z-scores, and then we use a calculator to compute the area under the curve, and that is the probability. So we can use a calculator. The normal CDF function will compute the area under the curve between these two z-scores. And if you want to use Wolfram Alpha, you can use this same command here, and then it will give you a bunch of different outputs. And the one that you're interested in is the inner output, the probability that it's in between these two. That's what inner means. And so you'll look for the inner here. And you might test it out by doing one that we've already tried in class to make sure you can work this out. So let's go ahead and take a look at an example. There's going to be 3 examples that you're going to do. The first one I will kind of guide you through a little bit, and then the second 2 you can tackle on your own. So the distribution of lifetimes of a particular brand of tire is approximately normal, with a mean of 51,200 miles and a standard deviation of 8,200 miles. We want to find the probability of a randomly selected tire that lasts, and then there are 3 options, and the 4th is an explanation. So the first is between 55,000 and 65,000 miles. Now it's important that you sketch the curve out, and so and show the area which you're trying to find, and you'll see what I mean by that if you aren't completely sure. So go ahead and try this on your own, sketch it out. You should be able to do this perfectly fine, and we'll take a look at some of these solutions in a second. All right, so for number 1, we want to know in between 55 and 65. So here's my normal curve with a couple standard deviations, and 55 is going to be somewhere in between the mean of 51.2 and the first standard deviation. So somewhere around here is where 55 is going to be, and 65 is going to be somewhere about here. Okay, so I can do a quick estimate. Maybe I think that's about 20% of the data or something like that, and so then I can use the z-scores from each of these, and with those z-scores I can then compute the area under the curve. Okay? What I'm going to do is I'm going to work on number 2, so that's the one that we're going to see here. So 48,000 is going to be a little bit less than the mean, and I want to know the probability that it's less than, meaning everything to the left, the area under the curve to the left of 48. And so here my higher z-score is going to be the z-score at 48,000, and the lower z-score, what we want to think about is that we want it to include everything to the left. So let's choose a really big z-score that would be far out to the left. And so you might choose a z-score, and I usually use -999. And if I were choosing one far out to the right, I would use +999. And so what I can do is I can use the normal CDF to compute this area. So the z-score for 48,000 is negative 0.39. My left-hand z-score is going to be negative 999. My right-hand z-score is negative 0.39. And this is going to be approximately 0.348. Okay? So that's the probability of getting something less, getting a tire that will last less than 48,000 miles. In other words, we expect this to happen 34.8% of the time, right? Okay, so you can go ahead and compute then for 1, 2, 3, and 4. And for 4, make sure that you're using coherent English sentences to do this. And now I'm going to show you the next couple of questions, which are very similar to these, and will give you a little more practice and a little more challenge. All right, and then here's the next one. Just a heads up, this one's going to be tricky. Make sure you sketch it out. If you can do this, you should feel really confident that you're going to be scoring in the upper level on any quizzes.